Thank you so much for joining us. We are super excited to have you. My name is Ryan Musto. I'm an investor at Alumni Ventures. Thank you. Yeah, give it up. Welcome to America Assembled. You know, you have a lot of options for Tech Week, so we appreciate you making some time for us. Thank you to Lucid. They'll say a word in a moment, but this beautiful space. Give it up for these guys. Gosh. I'm going to keep it super brief because the real stars of the show, it's startups. So want to give a bunch of time to them. But, you know, a little bit about Alumni Ventures. We're a seed through Series B funds. We're generalists, but we've been spending a ton of time in advanced manufacturing and robotics. And it's for a reason that's probably obvious to all of you because you're here. There's a ton of supply chain disruption these days. And we are huge believers that American startups are best positioned to act, react, problem solve, and ultimately benefit in a macro condition where there's a lot of chaos. So we are investing in those startups pretty aggressively, and we've invited a bunch of them here today to share some of their thoughts with you all. So going to hand it off to Lucid right now, but thanks again for coming. We really appreciate it.
Everybody, thanks for coming.
My name is Tim. I'm the studio manager here at Lucid Motors, and excited to have you all here. How many of you heard of Lucid before? Yeah, you know, a little bit ago, there wouldn't have been that many hands, surprisingly enough. But we're starting to make our mark. Little history about us. We were a company known as Ativa, founded back in 2007. We created all the battery tech for Formula E racing. Not sure if any of you are familiar with that, but and then about 2014, that's when Lucid was founded with our former CEO, Peter Rawlinson, and they created the name Lucid because they thought Ativa sounded too much like a Greek yogurt. So, but we are the longest range electric car company on the market. We get up to 500 miles of range on the Air sedan and up to 450 miles of range on our brand new SUV, the Lucid Gravity. So this is the latest and greatest of our technology right now, and I think it's going to be a game changer for our company. But I just wanted to welcome you all here, and thanks so much.
New lab.
I didn't prep for this at all, but so hi guys, I'm Prad. New Lab. I'm the head of defense at New Lab, which is a critical infrastructure platform, and big fans of Alumni. We do like everything together and Sherman as well. So New Lab is a critical infrastructure platform that's right now it's headquartered in the Brooklyn Navy Yard, but we have locations in Detroit, in Louisiana, in Riyadh, Saudi, and in Montevideo, Uruguay, and we're expanding as well on our growth stage. What we do is kind of three things. We provide critical infrastructure for startups and companies looking to prototype and test designs. So we have prototyping labs all over machine shops, wood shops, et cetera. That's cool. And then we also help startups operate testing. So like autonomous testing. So we operate drone corridors, private roads for autonomous vehicle testing. We help operate a port in Michigan. We work with Justin to do manufacturing in Michigan. So we want to help startups do a full vertical stack from prototyping, design, testing, manufacturing, full-scale production, all the way through. And so that's kind of what we focus on. We work heavily with state governments to unlock these infrastructure assets and subsidies and blended capital solutions so that we can make that more available, better, faster, cheaper for startups. My background, I've been a founder myself in hard tech, sold a company and worked formerly at Firefly Aerospace. And it took us like forever to get permitting for testing rocket engines, but we've actually tested rocket engines in the Brooklyn Navy Yard. And so I think if you're a hard tech company or startup and looking for a place to build, to test, to deploy, to manufacture, see New Lab as like, hey, we're headquartered here, you can do that here, but also access our full global network of assets around the world. And our partnership with the state allows the economic development angle for workforce development, and that we see startups creating jobs, et cetera, kind of driving that funding. So we're funded mostly by economic development dollars from the state and locals. By federal dollars, we have a lot of DARPA contracts. We work with DARPA very closely. And so if you're a startup looking to build anywhere in anything in hardware, and we now do software, we focus on critical technologies. So kind of like everything that's non-lethal, that's kind of what we focus on right now at the moment. And so come find me afterwards. We're happy to talk and share. So thanks everyone for coming. And thanks for hosting, Ryan.
Hey guys, my name is Sherman Williams. I'm the managing partner of AIN Ventures. We are a pre-seed, seed stage deep technology fund, and we specialize in those companies that are dual use. We invest in areas from space technology, life sciences, artificial intelligence, machine learning developer tools. We do several areas of sustainability tech, so it's really cool to be here at the Lucid facility. We are actually based right here in Meatpacking. So if you ever want to get hot chocolate, Cobrick, that's my spot. Chai tea at the Starbucks across the street. We've got a Sweet Green over here, et cetera. You'll see me walking around here a lot, talking to founders on my phone, et cetera. I love this neighborhood. I live and work in this neighborhood, so it's really exciting to be here. Something else about us is we actually have money from the state of New York for our fund. So I am we're very active check writers right now, extremely active. We closed our fund one last year, and we have, for the state of New York money, we have to deploy the money back into companies that are based in the state of New York. So if anyone is building, you have friends that are building, colleagues, anyone that's building, please let us know. We come in extremely early, pre-seed and seed stage. By the way, we also have that deal for the state of Maryland, Virginia. So if you know any folks around there also, please let us know. Super excited to have you guys here. What we're going to do today is we're going to bring up a founder, maybe more if Drew, or we have two founders, okay? I'll introduce the first one, then Drew, you introduce the second one then. All right, so we're going to bring in some founders that are in and around the robotic space. So first, you have Xavier Shi. Him and his co-founder, Sebastian, they have a company named Embody. It's a spatial AI company, so it works heavily with robotics. They actually are graduating from Y Combinator next week, demo day. Yep, they're based here in New York City. So the team, we moved back here to New York. So I want him to come up and tell us for about 2 to 3 minutes about you, and then we'll introduce you next time.
All right, thanks for the introduction. So, you guys love robots? Great. Yeah, an interesting fact. Actually, the world is way less automated than most people thought. Like, we definitely want more robots. However, robots, it's really, really hard to use. It takes a long time and a very high level of expertise to program. So that's actually a fundamental problem, like preventing mass adoption of robots. And what we are doing, quick introduction about myself. So I'm Xavier. I am co-founder of Embody. We start spring last year, a year from now. And before that, I worked at Google, actually just 2 blocks away, back there. For a little bit over 4 years, I was the tech lead of the Google public DNS team, where we were managing the whole world's internet traffic. And now working on robotics. And the thing we do is we have an AI software, a platform that can be plugged into any robots, initially targeting industrial robots. So anyone can just simply go to the robot and talk to the robot to teach about new skills, and the robot will run it reliably in production. And one interesting and example use case that we saw for one of our customer, a Fortune 500 manufacturer, is they have to package a new product every day. And it's just a different combination every time, every day, or even every week. Traditionally, it needs a long time to program these robots and also require a very high level expertise. So with our software, basically anyone in the factory just go to a robot and interact with the robot like a person, and the robot will do it reliably by itself in production. And what we are trying to achieve is to turn these robots more like consumer commodities and massive adoption. So that's what we've been doing. And hopefully the industry will we'll see more and more robots everywhere. All right. Thanks.
Thank you. So I'm Alex Piper with Intramotive. I was asked to speak about 30 seconds ago, so apologies for my lack of preparedness here. But we are a startup based out of St. Louis, closed our Series A last year, and want to thank Alumni Ventures for being a part of that and putting me on the spot here today. So we build battery electric autonomous freight rail cars. So we are one of the maybe bigger robotics companies or make bigger robots than most. And we're really proud to be a part of the American advanced manufacturing scene, making something that, you know, we have advanced technologies that we're making, but we also are an enabling technology for additional manufacturing use cases. So we really want to make rail competitive with trucking again and enable quicker transit times, lower transportation costs so that we can make the small American manufacturer more competitive again. So I want to thank Alumni, and also since New Lab is here, I'll also give you all a shout out. Appreciate them, and we'll plug the event that they're doing in Detroit this summer. So I believe our teams are actually on a call right now discussing a full-size rail car demo at their facility. So we are going to be demoing one of our autonomous freight rail cars, very large piece of equipment at their facility in Detroit, and it should be a fun event. So thank you all, and thanks again for Alumni.
So maybe to kick things off here, let's just go down the line, and we'd love to get some intros out of the way, who you are, what you do, etc.
Hey guys, I'm Anthony, co-founder of Artifact with Corbin, he's back there too. So we're building software for electrical system designers. So everything from conceptual design, detail design, procurement, vendor management, manufacturing, really going through the whole stack of how do complex electrical systems get designed and made. We're building the software for that. So prior to this, we come from the aerospace world, so we're both really hardcore hardware nerds. I was working at Boom Supersonic. They recently went supersonic earlier this year, and then spent a couple of years at Hermeus leading their avionics team. And 2 weeks ago, they actually flew too. So it's been a good quarter. So yeah, we're super stoked to get to chat a little bit about manufacturing and really what this looks like in America.
I'm Ed Bear, a CEO co-founder of Machina Labs, engineer by background. Spent early days of my career in robotics and artificial intelligence, both academically and in the industry. Then went to SpaceX, so I was control engineer there, worked on different parts of the stack, but that's where I started focus more on manufacturing side, and kind of realized how challenging manufacturing is today. Every time you pretty much have to build a physical product, you have to build a factory for it. Elon famously said, factory is the actual product, because the factory is very specifically built for the product you're trying to build. The moment you want to change your design, you want to change your material, you have to change your factory. So since then, I've been in agile manufacturing, started Machina in 2019. The goal is to build robotic systems that can do different types of manufacturing operations autonomously without the need for new tooling, new hardware. Just through change in software, you can go from like forming sheet metal to do trimming to do additive manufacturing, right? So you can truly have a flexible factory that can be programmed to do different types of parts.
Hey guys, I'm Phil. I'm the co-founder and CEO of a company called Dirac. We are based here in New York. We just moved into a cool new office in the Empire State Building. What better place to help rebuild the American empire than from its Capitol building in its capital city? My background's originally in electrical engineering and robotics. Spent a little bit of time over at Northrop Grumman. Got to his clearance, worked on some pretty cool radar stuff over there. Did some electrical engineering work, some mechanical engineering work, some technician work. Just got to see how ridiculously archaic all the infrastructure was on the manufacturing side of things, of what to me seemed like a pretty advanced company on the engineering side of things. And I wanted to do something about it. I was starting to get the feeling that the West was forgetting how to build great things, and I wanted to make sure that didn't happen. So I got my best friend and co-founder, Peter, and we set up to go build our company. We have built what we call the first automated work instruction platform. If you're familiar with work instructions, actually, show of hands, has anybody ever heard of work instructions? Very, very low amount of hand raises, but definitely some. But in fact, pretty much everybody here probably has, if you've ever built IKEA furniture. That little paper instruction book that tells you how to build a thing. Turns out, everything around us was built by someone, a operator or technician in a factory. And turns out they need instructions too. Turns out those instructions look like several hundred-page PowerPoints that are compiled over the course of weeks or months. Super manual, super brutal. we built what we call the first automated work instruction platform. So we take a CAD file as an input, figure out the assembly sequence automatically, then automatically generate 80 to 90% of your assembly work instruction. That lies at the root of what we call, unfortunately, the tribal knowledge problem, right? There is an enormous amount of context that is being lost, not only as folks retire, but as folks don't actually write things down when they're doing production planning. So at the root of what we're driving is what we call context-aware production planning. And so that's what I love to talk about. It's what I'm doing here.
Awesome. I'm Alan Gibson at Formic Technologies. I really come to Formic as an end user of robotics. So I led all of Stanley Black & Decker and the Estee Lauder Company's manufacturing equipment operations for a number of years, which essentially gives me the perspective of our customers. So I largely go in to make sure that when we're deploying systems, that they are reliable systems that the customer is going to be able to use for a long period of time in a reliable way. So that's really my role now at Formic, and excited to see the industry as it continues to evolve and grow and broaden outside of just manufacturing into the rest of the economy.
Alrighty, so softball to start us off here. Obviously a ton of noise these days about onshoring. Adoption is quite uneven across different sectors, industries, etc. What structural or cultural barriers do you see in reshoring at scale? And how are your individual teams working to overcome some of these discrepancies across different industries?
Yeah, so in my past life, there's a lot of how do you actually build avionics? How do you build complex electronics? And a lot of people don't know that currently how people procure some of the most expensive, long lead, high stakes electronics is actually kind of like a travel agency. You're calling some guy, they give you this long line card, and you're really just playing this whole game of like, all right, well, my buddy Steve, gave me some ideas on what hardware to buy. And it really is like the travel agency model where, hey, like you're really going off of who you know and who can sell you on something. They're wearing their typical engineer button down, veneers, it's crazy, whole thing. And really the idea is like, hey, how do you actually make the industry a lot more competitive, right? How do you find the people building the most compelling hardware out there and then give them the tools they need to make smarter supply chain decisions, right? You're kind of making the Google flights of it. So a big thing about how we're thinking about building Artifact is saying, hey, like, how do we actually be way more transparent about where your parts are coming from, who's building them, how fast can they get it to you, what are the capabilities, all these things. And really you start to incentivize things that are like, you're onshoring things, you're not just doing the whole branding problem of American manufacturing, but you really get to see the whole value chain and how it's gonna affect the end user at the end of the day. So yeah, structurally, there's the whole, like, how do you actually make things clear to the actual engineer so they can make clear decisions?
To me, as you explained, I think manufacturing is like this complex web of supply chain, right? So when we talk about reshoring, we need to be aware that there's a whole bunch that needs to come back before we can kind of reshore one part of it, right? Because that whole web, to some extent, has dependencies to foreign suppliers. And that's why actually you see most of the new manufacturers go end-to-end and fully verticalized. Like, when we were at SpaceX, we wanted to work with different vendors, right? But you can't find them. Like, you can't find good vendors you can work with. So you end up deciding, okay, some of this you're going to bring in-house, right? So I think basically what I'm trying to say is for manufacturing to come back to the United States, we're going to see probably a lot of fully verticalized manufacturers. But also we need to completely change the cultural perspective that we have on manufacturing, right? Because for the past 30, 40 years, we have been outsourcing our supply chain to other countries. We also lost our ability, as he was saying, lost our ability to build stuff, right? So that will take some time. That will take some time, and it requires a lot of cultural change, and also valuing manufacturing again more than we do today.
Yeah, it's funny enough. Yeah, very similar perspective on it. When you look at automation and technology adoption across the whole ecosystem of manufacturing, it's very saying the manufacturing world is like so vague. It like doesn't even really make sense to even say that. what I've seen and what we're seeing is if you look at the way that like companies get structured, the way that they interact with other companies that they supply from, you can describe that structure and that hierarchy as an OEM is sort of like the top level. They'll make a vehicle, right? They'll make like a plane, car, train, whatever. Then the companies that they source from, like let's say Boeing is an OEM, the company that makes the engine that they then put under the wing is not Boeing. Boeing sources that from General Electric or Rolls-Royce. Rolls-Royce in that case is called a tier 1 supplier. So when we talk about suppliers, we're talking about like tier 1 through 3 suppliers. And so what I've seen is there's a lot of very interesting, especially in like the startup ecosystem right now, there are a lot of folks who want to be, if you look at it like a pyramidal structure, there are a lot of people who want to be like the top level OEM and make like new attritable systems and sell to the DoD and like, wow, let's make more drones, awesome. And then there are a lot of people who want to make like parts better. And both of those are very critical, but something that I'm not seeing a ton of is the complex mechanical subassemblies that live underneath the hood. Complex, pumps, valves, things like that, heat exchangers, right? And like those are the core complex mechanical subassemblies that live on that basically delay any sort of like production timeline for an OEM. These are a ton of the customers that we work with, right? We work with OEMs and tier 1 through 3 suppliers. And so like what we're working on to make sure that this technology adoption is evenly distributed is working with and specifically targeting like a mid-market manufacturer that's like a tier 1, tier 2 supplier. I can tell you about like one of our customers is this company called Ankara, right? They make like 60% of all the cargo loading mechanisms on all the planes in the world, right? And if you look at a company like this, you can see this like really interesting like power law distribution across all these manufacturing companies for tech adoption, right? Like all the capital is concentrated in like the top 1% of OEMs, like the John Deeres and the Fords, and they have a ton of automation, ton of software. And then you look at literally everybody else, and it's like the 99% of people who just like are still on like paper binders for work instructions, still on like manual cards and whatnot. And it's, if we actually want to fully reshore, fully rebuild American manufacturing, we need to start focusing a lot more on those, tier 1 through 3 suppliers. So basically exactly what I was saying.
Yeah, I definitely agreed with the approach on the tiered suppliers. I mean, if you fundamentally think about it, the manufacturing that is still in the US is here for a very strategic reason. It's either DoD related or it's something that is such a large product from a shipping perspective, it doesn't make sense to ship it from overseas, right? So in order to sort of change this paradigm where we ship everything overseas that we can possibly do, we have to bring those supply chains back. But a lot of the challenges, bringing them back can't be brought back in the same way where they're made today, right? So, there's a lot of reshoring that's been going on for many years now. I mean, when I was at Stanley, I guess this is probably about 8 years ago or so, we were already reshoring back from China into the US because there was a marketing and a financial reason for doing so, but doing so had to be automated, where when we were in Asia, it was manual. And the issue with that is that when you design products to be built manually, it is substantially different than designing products to be built efficiently with automation. So we're going to have to overcome that design challenge as well, not purely just build a factory in the US and staff it with people.
So we've touched upon some of like the cultural things that need to change. So now maybe switching to the other side of the equation here, like if you had a magic wand and could get one policy, regulation, incentive, or otherwise passed that would accelerate American manufacturing, what do you think it would look like? Like your ideal, Senator.
I'm sure you guys are going to agree on this one. If we spun up trade schools and made them free, because the biggest issue that I see within manufacturing after it's already here, right, is that we don't have the people to support automation at the scale that we need to. Yes, at your large OEMs you do, because you've had packaging automation or robotics around automotive for many, many years. But for all of the other industries really outside of electronics, pharma, CPG, and automotive, adoption of automation has been very small. So we're going to have to upskill a tremendous amount of people, not to be operators on lines, because that's the processes that need to be automated, but the people that are going to support that automation and make sure that the production results come out of the equipment as they should.
That's true. So I've said this like once or twice before. If I could wave a magic wand, I would talk a lot more about tribal knowledge again, right? That is the context. That is the stuff that lives inside of the heads of the guys who've been on the shop floor for 30 years. We as a country have spent many years, spent billions, potentially trillions of dollars on environmental conservation. We have spent roughly $0 on tribal knowledge conservation. Wave a magic wand, I would do something akin to like the Office of Shipbuilding, but Office of Tribal Knowledge Preservation. This is we could literally send college kids to production facilities and just sit with one of the guys on the shop floor, one of the old dudes, and just write stuff down. Like we have in the past as a country made an intentional effort to catalog information, to catalog historical information, to do some of these like historical, cataloging events, right? After World War II, I know this happened. It is in our best interest as a country to make an effort out of this. It probably wouldn't even be that expensive. It is just a little bit of effort and some intention, and it would literally drive us significantly more forward than anybody would probably even expect.
One thing that government can do really here is making CapEx a little bit cheaper, right? Like there's a lot of work that can be done there. There is this misperception, I think, still exists within the investor community that hardware businesses are not good investment. Some of it is because of CapEx, and some of it I think is actually misperception, right? I think with AI now, I think we're getting to the point where services businesses, software businesses are going to have a very limited moat, right? You can come up with a service and then probably in 6 months, 7 months, somebody else can disrupt you and push you out of it. Services that are not related to the hardware, right? So I think if you can kind of adjust some policy so that the CapEx becomes cheaper for the companies, I think we're going to give a little bit of a buffer for investors to adjust their perception around hardware businesses being too expensive or too CapEx intensive to invest in.
Actually, quick aside, I was talking to a founder recently who had this bit that welders and people who do carbon fiber layup are artisans, not trade. I figured you'd appreciate that. Just because like the number of people who know how to do it has gone down so that like everyone who can weld great is actually Picasso. Figured you'd appreciate that. No, I think the biggest regulatory thing is like this dirty word compliance in aviation, in like military construction. And really there's like a very specific difference between compliance and quality, which I feel like I always have to break people's brains over like what the difference is. Now, compliance is just a piece of paper that has like some ink signed on it, right? But like if you look at your iPhone, it is this beautiful, beautiful piece of engineering. There's nothing compliant about an iPhone, but like you can take apart like $1 million avionics boxes and it's the most like hodgepodge, hot glued, white wired, nasty thing. But it definitely has that piece of paper that was signed with, like that person in the FAA or whatever. And I think like if there's anything that I can break, it's like how do we think about our defense orders, our MIL standards, our FAA compliance processes that actually incentivize quality and modernization of the hardware that we're building, not just, hey, this thing that they bought 30 years ago, and you have this nasty sustainment stickiness problem, which kind of like anchors these like OEMs, these tier one suppliers into just bad hardware that they're stuck with very easily. Like changing that incentive would be huge.
To that point, I call that checklist culture. It is sort of like the abdication of agency and autonomy of engineers over the pride and quality of the work that they do. This is, I think, like one of the problems with the aviation industry and in general, like just production in general, right? We used to take pride in our work. Now somebody says, here's a checklist, make sure, make sure all these things check the box, and that abdication of pride has, I think, not only decreased quality, but also, led to a bunch of other snowball effects.
We have such a diverse group of businesses up here doing so many different things across the space. I'd be curious to know if you guys have encountered any sort of like manufacturing bottlenecks or challenges over the course of building the business or in your conversations with customers or prospective customers. And would be curious to hear if any of these bottlenecks or challenges were like really surprising, right? Things that you did not intend when you set out to build a business in the first place. And how did you solve it, / are still trying to solve it?
I think the most surprising thing that we saw, which I knew kind of theoretically, but once we get to the business, we realized, is that kind of goes back to the point I brought up earlier, is that manufacturing this complex web of supply chain, you improve one piece of that. Like, think of it as like, kind of raw material coming in on one end and this graph of different nodes in it, and then on the other end comes out the product. So it's a very complicated graph in the middle. So if you improve just one graph, which is traditional thinking, like just improve one node, right? If people who are familiar with graph theory might not necessarily improve the full throughput of this graph, right? So you might still, like, you can make one part of the graph really, really performant, but still that was not the bottleneck. Now some other part is the bottleneck, right? So it's still slow. So one thing we realized very fast was you need to start from one node, but expand your capability more and more until you actually deliver 10 times improvement at the end of the graph, right? Which makes it, I think, significantly harder than a lot of other businesses that could be point businesses, right? We knew it in theory, but in practice, like, it was a painful learning experience.
So awesome to hear you describe it as a graph. I've never heard the way that we think about production at Dirac is like a graph, right? So like exactly how you described it. What we're trying to do, what we're building, is a hard-coded, very, very deeply opinionated, high-speed rail for that graph. Like the best practices, encoding them, because we get to see and work with a ton of different manufacturing companies across tons of different industries: automotive, aerospace and defense, ag and construction machinery. And so we just get to see all the best practices. We see high mix, low volume, low mix, high volume. We get to see how can we take a high mix, low volume producer and improve their mix. How can we or improve their capability to handle high variance. And then we, in general, have seen companies. I would say some of the most painful bottlenecks. Just to answer your question a little bit more directly, some of the most painful bottlenecks that I've seen are folks on the shop floor who see the problems day to day. I don't run a manufacturing facility, but I just see this over and over again. They want to make a change. They want to make a difference. They see where improvements can be made, but generally they are afraid to bring that to management. They're, a operator on the floor, wants to keep their head down. They don't feel like they have that agency, that autonomy. They don't feel like they can bring up that, like, hey, if we bring this tool in, or if we reconfigure this line a little bit, we can see this sort of outcome. And who knows better than the guys actually on the floor doing the work? And so I would say that disconnect bottlenecks a ton of manufacturers. It's the inability for operators and production planners and guys actually doing the work on the shop floor to get feedback and convey optimizations in an effective way to folks who can actually do something about it. I would say, yeah, drives a ton of issues.
Yeah, so at least in my background of doing like the R&D one-off products or even the low-rate production stuff, it's wildly asymmetric, the things that end up being massively expensive to these companies. Like at Hermes, I was doing some analysis on like the electrical design problem. And it turns out if you take all of the labor, all of the design, like 8 months of effort to design like the crazy avionics of an aircraft, that was about a fifth of the company cost to the 2 weeks that we're on the runway troubleshooting a landing gear. All right, like it is clear that I was not getting paid enough. Like that was the obvious takeaway that I had. But no, like it really is like, what are the big bottlenecks? What are like the big values that you can provide these companies that are creating like some of the most like interesting pieces of hardware? And it ends up being like, how do you actually not just do a point design of a solution? You're like, what is the perfect airplane? That's actually not the problem. It's like, what's the most robust design and set of designs? And this includes supply chain. This includes how you manufacture. It's like, what are all the things that I can do to cover my ass when something inevitably goes wrong? And that's the actual problem, right? So when you start thinking about bottlenecks, it's not just one bottleneck. It's not just a single bottleneck for a detailed design, but really it's how do we actually build a system that's super robust to handling every single thing that's going to break. And really it's like taking all of the potential bottlenecks and making them all shorter all at once. So it ends up being much more of a systems problem than necessarily like any one thing. And like it's insane, like just how wildly asymmetric it is for a company that's hundreds of employees, because any one employee's labor hours is wild to compared to like an entire company's critical path shifting an hour. So that was a huge thing.
Yeah, for me, I mean, to me, the biggest issues that we have from a bottleneck perspective are really oddly financial. And what I mean by that is in manufacturing environments, everything still has to be, it's a business, everything still has to be financially justifiable. And largely, you have to continuously expand sort of the breadth of what you're trying to automate in order to get to a justifiable place. In a lot of ways, like what Ed was talking about, in traditional manufacturing, like lean manufacturing, you have to make sure that you're not just moving a bottleneck, right? Moving the problem further down the line, because at the end of the day, in order to get any financial benefit out of any technology, it has to actually impact the bottom line of a business. And you can't just deploy a little piece of automation as a silo into a factory floor and expect to get any meaningful benefit out of that. So largely what you see is the companies that have been really successful with automation have taken segments and completely redone them, right? So if you think about CPG and making toilet paper, right? That is a fully automated process that people monitor. Whereas if you look at a lot of the processes that are not currently in the US, those processes are largely manual and done by humans, and there's not yet machinery that is doing those. So like the custom automation space is solving for each of those individual challenges, and it's partially because we don't have generalized enough robotics, which is largely under development. But there's also that financial component of how broad you have to base your technology in order to be justifiable, and then to some degree you're general in nature, right? And you can't address those more specific problems like Anthony was mentioning.
As we come up on our time here, I would be remiss if I didn't ask a question that I think is like on everybody's mind, right? Which is like, how do you balance the promise of automation with workforce dynamics? Are technologies replacing jobs? Are these technologies creating new ones? Both. Would be curious to hear you guys opine on that, because I think it's a really important one.
So there are a lot of ways that people talk about technology that are bad, right? When people talk about AI, they're like, it's going to take all the jobs, it's going to automate everything. That's not generally true, nor is that good. There is, I keep getting back to like context, right? There are, in the US, we do not want cheap labor, we want smart labor, right? We do not want, generally speaking, like 100% fully automated tools. We want humans in the loop, right? What we're building is not a fully automated thing, it's an 80-20 tool. That's how we sell it, that's how we pitch it. Also, like traditionally in manufacturing, past 20, 30 years, probably let's say 20, manufacturers have been being like, Silicon Valley folks will come to manufacturing facilities and say, we're going to sell you this magic fancy ERP and it's going to save your life. And the guy who was doing things manually, pen and paper, now does things manually, but on a computer. So didn't actually improve his quality of life. Now he just, management really liked it. And so you got to like frame that reference for you that, these folks have been being sold like gobbledygook, fancy schmancy, wizard software for 20 years, 30 years maybe, and it hasn't actually changed their quality of life that much. CAD software, at its advent, like did actually save some people a lot of time and effort, still does. But like by and large, most software for manufacturing doesn't actually improve their quality of life. That's why what we're trying to build radically does. Like that is why we've had really great adoption. But when you think about, the future of working with a manufacturing facility, you have to understand that it does have, the people there have this long history, have this long legacy, and you have to meet your customer where they are. You have to understand how to interact with them, how to interface with them, and don't sell like a magic pill Like, sell a solution to a real problem and really, really deeply understand that problem, spend time with your customer, really spend time building a relationship with them. And like that is kind of what I think is like the best way to compromise and work towards a better, more automated future for American production.
So first of all, on the workforce problem, like we are hiring people and we can't find them. So I don't know where the workforce problem is. Like replacing jobs. Most of the stuff that we're talking about, honestly, like America doesn't have an industrial base. If you really want to be honest, there's some industries that we have, like maybe in aerospace defense, we have some like older, kind of industrial base, but we don't really have an organic industrial base, like compared to Southeast Asia. So we're not really talking about getting anybody's jobs away. We're talking about, okay, let's bring some of this back, and there's nobody's that actually doing it. So let's add some automation in there. So overall, I think it's going to be net gain. So I think that's a myth that just automation will remove, people from their jobs. And the last thing I want to add is the future is going to be hopefully drastically different from today, right? We need to go to space. We need to have a shit ton of satellites up in the, in the orbit. We need to go to other planets. We need to have flying cars that were promised in 1960s. We need to have so many products that we don't have today. So the market significantly will increase. I think there are going to be more people working in this sector as a result of automation because now there's capability to actually do things. But a lot of times also automation enables you to do things you couldn't even do before, right? With our forming process, for example, now you can form high temperature alloys much more cost effectively than you could before. We actually worked with Hermes a little bit on that one. So it's open up new doors of things that wasn't even traditionally possible. So I think this whole narrative of doom and gloom that, it's going to replace our jobs, like this has happened with every technology that came out and never was the case. So I would say, yeah, it's just a little bit of a moot discussion.
Yeah, so Corbin and I are working on the generative AI co-pilot tools. So I think like right now it's like everyone who's a software engineer is like very scared of all the cursors. So we get this question a lot. And I think typically there's a very large variance between how people think about, hey, like are the hardware engineers going away when ChatGPT gets really, really good at building hardware? Now, I think like I go back to like designing these electrical systems, designing these circuit boards, and kind of like Phil was saying, like there often is a human in the loop. But something we get often is like, oh man, my job's going to be so easy when this AI tool can read all the data sheets, it can generate all the things. And I'm like, oh my God, dude, I disagree with you so hard. Your job's going to be so much harder because all the easy clerical misses that's the stuff that's getting automated, right? And I think like the cool thing about these new tools is like, not only can you develop crazy complex systems that are wildly impressive, but it actually starts to filter out for like the only people who can change the world are the smartest engineers. So the bar just gets so much higher. But what that means is they can do incredible things, right? Like people can do now with Cursor, like what no one could possibly imagine, not even the best software engineers could imagine. And I got really excited about what that means for hardware. Is it makes it harder. The bar is definitely raised. But like I expect with these new AI tools, with these AI co-pilots, people are going to be sending people to space and sending up some satellites at a rate and at a quality that we've never been able to achieve before.
Yeah, so I've worked across a lot of different industries. Coming out of school, I worked in oil and gas. I wrote software in oil and gas. Then I moved to manufacturing, power tools. I always joke that was my dad's favorite job for me. And then I moved to Estee Lauder, which was my mom's favorite job for me. And then I went into the startup space, which was my favorite job. And in all of those spaces, I've been deploying automation the entire time, my entire career. It's what I always have done. And not in any of those situations has it resulted in the true removal of a person from an operation. It's almost always reallocation of that person to a different task that's honestly always harder to automate, right? So eventually we'll get to the point where there is less people doing hand work, assembly work within manufacturing, but that is a really, really long ways away. And it for various reasons, not technology, but really anything that you can imagine.
Well, on that note, it is time for happy hour. Everybody, please join me in thanking these awesome speakers.
Thank you.